Okay, in this video, we're going to talk about cis and trans isomers. So we've dealt with isomers before. Isomers are compounds that are constructed from the same atoms, but that are still different from one another. And I think the type of isomers that we've talked about already are constitutional isomers. So uh, we have the same atoms, but they're connected differently. Right, we have the difference between ethanol and dimethyl ether. And even though they both have 2 carbons, 6 hydrogens, and 1 oxygen, because they're connected differently, they are actually different compounds, right? And just an example of a property that differs between them: the boiling point of ethanol is 78.4 degrees Celsius, and the boiling point of dimethyl ether is negative 24 degrees Celsius. Another type of isomerism is stereoisomerism. And so the molecular formula is the same, and they're actually connected the same. However, they have different spatial orientations. And there are a couple of different types of stereoisomers that we're going to talk about. The first one has to do with cis and trans isomers, and this involves molecules that have double bonds. Right, so unlike single bonds, it's not possible to rotate about double bonds. Right, if this had been a single bond here, and I could freely rotate around it, then these would have been the same molecules. However, because I can't rotate the double bond, right, if I try to rotate this CH2 group, right, that's going to remove the pi-pi interaction and break that double bond. And so that makes these different compounds because I can't do that rotation. And so I have the same atoms, and they're basically connected in the same order, but the spatial orientation is different. And so that's what makes them stereoisomers. Now, the labels we use to differentiate the two isomers are cis and trans. And what we're looking at are uh, the two groups that are the same on the same side or on opposite sides of the double bond. And so in order to have cis and trans isomerism, we need to have at least one of the groups on each of the carbons be the same, right? So this carbon has a methyl group, this carbon has a methyl group, so we can have cis and trans isomers. So when those identical groups are on the same side of the double bond, they're cis. In this case, one is up, the other one is down, so they're on opposite sides, and that's trans. And so I think this reiterates what we just talked about. For cis, the identical groups are on the same side. Trans are on the opposite side. Right. So in this case, both fluorines are down. So that's going to be cis. In this case, my common group is I have an ethyl group and an ethyl group. They're on opposite sides. One's up, one's down. So that's trans. Right. At first glance, it may look like we don't have identical groups, right? Because a fluorine is not the same as a methyl. But we got to remember we got hydrogens coming off, and so the hydrogens count as groups. And so one hydrogen's up, one hydrogen's down. So that's going to be trans. If we find ourselves in a situation where I have identical groups on the same carbon, then we don't have cis and trans isomerism, right? So in this case, these two molecules are actually the same, right? If I just flip this one over, I'm going to get this molecule. So no rotation of the bond is required. If I flip the whole molecule, I can go back and forth between these. So these are in fact the same molecule, and so they don't have cis and trans isomers, right? Neither does this one. I've got whatever this is, a butyl group and a hydrogen, right? Because I have two methyl groups here. This molecule does not have cis and trans isomers. Another type of cis and trans isomerism has to do with di-substituted cycloalkanes, right? And so if I've got two identical groups coming off my cycloalkane, if they're both up in this case, then that's going to be cis. If I've got one up and one down, that's going to be trans. So if we want to indicate whether each of the following molecules are cis-trans or not stereoisomeric, and so in this case, I have a hydrogen and a hydrogen. They're across from each other, so that's going to be trans. In this case, my two methyl groups are both up, right? If this one had been axial, it would have been down, right? Because equatorial, we would call it up. This one's also obviously up, so this would be cis. And then for this molecule, on this carbon, I have a 1, 2, 3, 4, and a 1, 2, 3, 4, right? So because these two groups are identical on the same carbon, that one is not going to be stereoisomeric. Now, these cis and trans labels don't work for all stereoisomeric alkenes. This molecule, because it doesn't have identical groups on the different carbon atoms, right? I can't use my cis and trans labels. And so at the end of this chapter, we'll talk about the E and Z designations, and I have another video on that topic.